Earth is made up of 7.7 billion people, but only half the world has access to digital technology. We are committed to helping close the digital divide by finding new ways to empower the unempowered. When it comes to environment, only 11% of the world uses renewables, with the rest still suffering from the challenges brought by legacy energy sources. Advances in digital technology.
All of us. Remember your childhood dreams? We all had them. Did yours come true? Alejandro had dreams. Watching his father install antennas inspired Alejandro's fascination with information travel. Alejandro's first job? As a telecommunications engineer, he turned his dream of making antenna magic into a reality through 5G technology. As a boy, James dreamed of faraway countries, new cultures, a fresh perspective. Today, his position introduces him to people from every corner of the globe, and he gets to learn about new cultures firsthand. The two had dreams of independence, a successful career, a voice that's heard. Her dream came true too. She's a project director, which empowers her to live her childhood dream every day. Khan played his first video game when he was 8. Now, he's developing leading-edge technology. It's the perfect balance of passion and profession. It's a dream come true. As a girl in a small Indonesian village, Mona Lisa only dreamed of traveling abroad. Back then, it didn't seem possible. Now, she's working with a multinational corporation and travels abroad daily. Dreams can come true. For as long as he can remember, Jakib dreamed of helping Morocco modernize. Today, he's doing just that by putting the latest technology to work in his home country. His life has direction and his days have meaning. His dream is really coming true. Our people come from 170 countries and regions. They may have different appearances, speak different languages, and come from completely different backgrounds. But one thing unites them all. They're dreamers. And they're not the only ones. This is Huawei. We value diversity. We fulfill dreams.
My name is Mona Lisa Marpau. When I was a little girl, I have a dream. I can travel all around the world.
I'm Joy, Administration Manager at Huawei Greece.
My name is Fatu Chun. I joined Huawei since the 1st March 2008.
3 years ago, Huawei is open vacancy. And then I applied it because I know Huawei is international company. I took the chance. Now I became channel manager here.
I joined Huawei in August 2011. It was a very difficult period for Greece because the economic crisis. For me, getting the opportunity within the crisis to be hired in a multinational company was like a gift given to me.
At the beginning, I was site engineer. In Huawei, everybody thinks that I'm not a woman, I'm a man. I want to go to site, show what I can do. I want to do more.
And now with Huawei, my dream is come true. I can go travel to around the world. I can see the other cultures. I can have Huawei colleague, friends from another country. So that's why I'm so happy work here because I can see what others cannot see. I will work hard and I will never give up with Huawei.
After 8 years working in Huawei, I must admit that I'm totally changed. Most people think that when a female wants to exploit and follow their career, they cannot have a personal life. This is wrong. If you are well in your personal life, then you can be amazing in your work.
If you stay at home, it is your husband who will do everything for you. And sometimes it is not easy. So I do my best to be independent, because if you are not independent, you cannot take fully decision by yourself.
You may feel as a superwoman or like a deadly woman at the end of the day, but you are full.
Huawei give me the chance to show myself. I'm very happy to work here.
I will continue to stick my dreams because I know Huawei can make it happen.
Don't believe everything you hear. Come and see us. Huawei Technology was founded in 1987. It has 188,000 employees globally, providing services to more than 3 billion people in over 170 countries. With its dreams in mind, Huawei learns from Europe and the world. Huawei works with many consulting firms around the world, building an international management platform. Huawei focuses on ICT and is committed to robust operations, continuous innovation and open cooperation. We aim to provide competitive ICT solutions, products and services to our customers. Serving our customers is the only reason for Huawei's existence. Regardless of earthquakes, tsunamis, hacker attacks or conflicts, Huawei employees from around the world spare no efforts to work with our customers and will maintain the stable, reliable and secure operations of networks and products. Because we believe, dream it possible.
It's not until you fall that you fly. When your dreams come alive, you're unstoppable. Take a
Don't believe everything you hear. Come and see us. Out of Huawei's 188,000 employees, over 80,000 work in R&D. Huawei invests over 10% of its revenue in R&D each year. As of December 31st, 2018, Huawei possesses 87,805 patents globally. The Noah's Ark Laboratory focuses on AI algorithms, including computer vision, natural language processing, searches and recommendations, inference and decision-making, human-machine interactions, and basic AI theories. AI is the Noah's Ark of Huawei when facing the torrent of big data in the future. As a general capability, it will transform every industry. The Network Technology Lab focuses on data communication, aiming to replace conventional electrical connectivity with optical connectivity and provide the basic core and transport network technologies that 5G relies on. The lossless cloud network supports the flexible, boundless scaling of services in a network for holographic communication. Immersive holographic videos are 50,000 times larger than 4K videos. Huawei is launching the industry's first ultra-high capacity, all-optical, cross-connection system architecture, improving overall energy efficiency by 100 times. The Thermal Laboratory, established in 2000, is committed to exploring innovative heat dissipation technology, which will boast better performance, enhanced energy efficiency, and be more environment friendly. This will support Huawei's continuous leadership in cloud, pipes, and device hardware. The Mechanical and Material Laboratory, established in 2012, focuses on ultra-precision mechanics, machining, surface processing, long-term reliability, etc. It works on basic mechanical and material science, innovation, R&D, and the application of related technologies. The UCD Center focuses on user experience research, human-machine interaction design, and user interface technology. It is committed to improving the usability of key products. This center supports the themed, creative work of all CPG products on all platforms and for all scenarios, running through the wonderful tunnel of space and time. Every step we take is a beautiful combination of technology and art. We have been dreaming of transcending space and time. We've never lost sight of this dream. Come and see us. You will find the future is close at hand. Welcome to the Independent Cybersecurity Lab. Huawei products have obtained 223 security certifications. The Independent Cybersecurity Lab implements strict management regulations. In terms of product design, development and delivery, Huawei always regards security and trustworthiness as strategic priorities. By referring to the industry-leading security and development model, we have built a corporate process for secure service delivery in order to rigorously test all Huawei products. The lab has an independent source code test zone that allows customers to conduct their own security tests. Huawei has established strict standards for testing product reliability. The security and trustworthiness of products are based on basic research innovation and a systematic guarantee mechanism. Since Huawei's founding, the company has never been involved in any major security incidents. Bringing discussions about technology back to technology. Don't believe everything you hear. Come and see us.
To trust or not to trust? That is the question.
Inventor Thomas Alva
We didn't trust it and tried to boycott it until the first light bulbs lit up the night.
and overnight transformed the whole appearance of the homes and streets of the civilized world.
We didn't trust it and we didn't trust it and condemned it as witchcraft when we first stood in front of a camera. We didn't trust it and pointed to failed test flights before the airplane changed the world.
Into the air for the first flight on record.
We didn't trust it when we saw the first steam engine, when we first used machinery, when we built the first skyscrapers, when voices crossed the globe in milliseconds, when we used computers,
Basic types of memory.
when we heard about AI or 5G. Whenever new technology is invented, we always question, worry, and fear
Then mellow, fun, order. And the
until we find
It's one small step for man, one giant leap for mankind.
have faith in humanity. Design tech for good. The future is what you make.
the Middle East. And so I hope you are doing well and you are keep safe during this tough time. In this challenging situation, we are continue work with our valued customer and partners to overcome this tough situation right now. We are much honored to have today opportunity to sharing the information about Huawei Fusion Solar Solutions during this event. Yeah, we are getting the opportunity to know about newest update about the Huawei Fusion Solar. If you got any question about this event today, you can just keep your message and your answer. Just left your message on the right side of the box, the chat box, and the question mode. Left your question and the message. We will answer you as the last part, Q&A. Okay, let's start the first section about the explored Huawei SEIEC. Thank you so much.
Everyone, good afternoon, ladies and gentlemen. We hope you're doing fine, keeping yourself safe during this hard time of this virus. My name is Omar Abu Najm. I'm responsible for the sales in Middle East and Africa region. And today, I'm going to talk and present the commercial and industrial smart PV solution, which is what we can provide from Huawei. My presentation will be divided into four main parts. The first one will be about our product portfolio and what we can offer to the market. The second part of my presentation will be about small-scale C&I application single inverter used. And the third one, the third part of my presentation will be about medium-scale C&I application, less than 10 inverter to be used. And the last one will be about large-scale C&I application for more than 10 inverter used. As we all know, Huawei can provide a very wide range of inverter that can suit all applications for commercial and industrial. And if I want to get started with our available product, I will be dividing them into four main families. As you can see in this, the first one is about our Sun 2000 12 and 15 and 17 and 20 KTL M0 and M2 version. And here is coming the most common question that we're having is, what is the difference between M2 and M0 version? The answer for this question will be that M2 version, it has a PID recovery system, which is, it doesn't have an M0 product. The M2 product will be available at the end of this year. Okay, talking more about this family, this inverter, it has a 2 MPPT stacker, 4 inputs. For local commissioning, you can use the built-in WLAN system, which is included in the, which is built in the system. For communication, you can use either the smart dongle. Okay, we're gonna stop for 1 minute. I think that we're having the slide problem. Well, I should start again. Okay, I will continue. Sorry for this issue in the presentation. As you all know, Huawei can provide a very wide range of inverters that can suit all applications for C&I, for commercial and industrial. And if I want to talk about them, I will be dividing them into 4 main families. The first one is about our Sun 2012, 15, 17, and 20 KTL M0 and M2 version. The most common question here that we're having is, what's the difference between M2 and M0 version? The answer for this question is really easy, that the M2 version, it has a PID recovery, which is, it doesn't have an M0 version. For this product, the M2 version will be available for all markets at the end of this year, or let's say H2 of this year. Okay, talking more about this family, it has a 2 MPPT tracker for inputs. For local commissioning, we are using the USB, the WLAN adapter, which is built in the inverter. For communication, we're gonna use the smart dongle for WLAN 4G, WLAN FE, or the smart dongle 4G, or the smart logger 3000A. For the arc fault circuit and PID recovery, both of them are available and built in with this model. Moving up to our next inverter, which is the Sun 2036 KTL. This inverter, it has a 4 MPPT tracker, 8 inputs. For local commissioning, we will use the USB WLAN adapter, which is, it's coming already within the box for free. For communication, this inverter is only compatible with the Smart Logger 3000A through RS485 cable. Arc fault circuit is also available for this product, but it will be an upgraded version, and it will be available at the end of the year. Moving up to our most common inverter in the market for commercial and industrial application, which is the Sun 2050 and 60 KTL M0. This inverter, it has a 6 MPPT tracker, 12 inputs. For local commissioning, we all also use the USB 2000C, which is already coming within the box of the inverter. For communication, you can use either the smart dongle 4G or the smart logger 3000A. For all of the communication devices, I will be talking about them in my next slide. Moving up to our last inverter for the C&I, which is we already launched in the 2020. Our latest inverter is the Sun 2100 KTL M1 version. This inverter, it has a 10 MPPT tracker, 20 inputs. For local commissioning, we are using the USB WLAN adapter, which is it's already coming within for free within the box. This is for commissioning. And for communication, you can use either the smart dongle 4G or the smart logger 3000A. For arc fault circuit and PID recovery, both of them are available for this device. Moving into my next slide, which is talking about the communication device options and what we can offer for communication to connect your plant or your project to our portal or to our Fusion Home Solar portal. I will be talking about the smart dongle WLAN FE, which is this dongle you can connect up to 10 inverters in series. Okay, it's really easy device, plug and play USB interface directly to the inverter. Through a Wi-Fi signal or fast Ethernet cable. You can use both, one of them. For the smart, moving on to the smart dongle 4G, it's similar to the WLAN FE dongle. You can connect up to 10 inverters in series. It's really easy. Also, a device, it's plug and play directly USB with the inverter, and you can use the 4G signal. Moving to our main communication center, which is the Smart Logger 3000A. This Smart Logger, it can support up to 80 inverters connecting in series for communication interface. To the inverter, you can use either RS485 cable or ACM bus system. Communication options to the cloud, either via Ethernet or 4G signal, which is already built in this Smart Logger. Local commissioning, and this is a really important point, and I would like to highlight it later in my slides, that you can do to save more cost in your side. You can do the local commissioning through the Smart Logger. If you're having multiple inverters, you can do the commissioning for the whole plant or for the whole inverters directly through the Smart Logger. Moving up to our USB adapter 2000C, as this device is already coming for free within the box for certain inverters. This device is only for commissioning purposes only. As long as I'm talking about commercial and industrial application, and as we all know, these applications might need sometimes for power control or zero export system. In this case, we should use the smart power meter or some smart power option. Okay. The power meter option, we can supply our smart power sensor, which is you can easily connect it through RS485 cable. Okay, through RS485 cable. This device, it is a class 1 high accuracy metering for production and consumption also. The CT is already coming for within the box of this power meter. The question also here is that if we want to implement another third-party power meter, there is a wait list that we can provide it from Huawei, which is the recommended power meters from Huawei side, and we're gonna share it with the clients, with the partners also. If your device is not on the list, you can contact us directly, or you can contact our VEPs to make it compatible through the MBUS registered map. Moving next to my second part of my presentation, which is the small-scale C&I application, single inverter use. I will be start talking about the smallest family from our side, which is the Sun 2012 up to 20 KTL, M0 and M2 version. Both are the same. Okay. Here, as you can see in the diagram, for local commissioning, we are using the WLAN, which is it's already built in this inverter. For any communication type, you can use either the 4G dongle or the smart Wi-Fi WLAN FE dongle to communicate or to connect your plant, your project directly to our portal through a Wi-Fi signal or a 4G signal, depends on the dongle that you are using. In this case, sometimes if we want to use the smart power meter in your project, for this inverters, you can connect directly the power meter directly to the inverter without any additional device. Moving up to our next inverter, which is the Sun 2036 KTL. This inverter, as I have said before, the local commissioning for this inverter will be done by the WLAN USB 2000C that is coming already within the box, for free within the box. For any communication system, you will use the Smart Logger, as this inverter is only compatible with the Smart Logger through RS485 cable. If you want to implement any meter or any weather station, any sensor, you can connect it directly to the smart logger. For commissioning, as I said before, this inverter you can commission through the USB that is coming for free within the box, or you can commission your project directly through the smart logger. For connecting your plant or your project directly to our platform, either you can use the 4G signal, which is already included in the smart logger, or the Ethernet Wi-Fi signal. Moving to much bigger scenarios, which is we're going to use here the 50 and 60 KTL M0. As we said before, this inverter also is only compatible with the smart logger or 4G dongle. But in this case, we are using the smart logger function. For commissioning the project, you're going to use the USB adapter, which is already coming within the inverter. Directly communicate your inverter through RS485 cable to the smart logger, so you can monitor your project and commission your project. And if you're having any other device or weather station or any sensor, you can connect it directly to the smart logger. For our new inverter, the 100 KTL, it's compatible with the 4G dongle and the smart logger, and I will be explaining both cases in my next slide. And this slide and my next slide. In this slide, we're going to talk about the 4G signal. This inverter is commissioned by USB adapter 2000C, which is already coming within the box of the inverter. For the 4G dongle, directly, it's really easy device, plug and play directly with the inverter through a 4G signal to our portal, to our web page. For any sensor that you want to connect it to your plant, and you are using the 100 KTL, you can connect the sensor directly to the inverter without any additional device. And the next case is about using the smart logger instead of using the 4G. If it's, I'm having like a plant where the Wi-Fi is available there. But if I'm having the smart logger, the communication is really easy. It's just an RS485 between the inverter and the smart logger. If I'm having any other sensor, weather station, any other device that I want to connect it to my plant and show the results in our portal, you can connect it directly to the smart logger. Okay, now we're going to talk about the medium scale C&I application, which is listed inverters. And here I would like to highlight very important point that regarding the design or using the smart way of designing the project, which is it will save a cost on the EPC or on the developer side. I will be explaining about this in this scenario. For example, I'm having a project that consists of multiple inverters, which is less than 10 inverters. One of them here, I'm using the 20 KTL, the 50 KTL, and the 36 KTL. And I connected them. I connected them together through RS485 cable directly to the master inverter. In this case, I know that the 20 KTL I'm using is already compatible with the smart dongle 4G or WLAN smart dongle, and I want to save cost in my side, which is why I should buy a smart logger in this case. As long as my inverter is already compatible with the dongle and with the 4G or with the WLAN dongle. So I will be connecting the inverters to RS485 cable to my master inverter, which is the 20 KTL. And in the other hand, I know that I can connect a smart power meter directly from directly through the inverter, through the master inverter. In this case, the 20 KTL will be the management system in my plant that I will control and monitor everything through this inverter without any additional cost for a smart logger or the communication cables like RS485 and this. Okay, moving to another scenario, which is in this case, I'm using the 50 KTL along with the 36 KTL. Okay, two of the 36 KTL, and I'm having one of the 50 or 60 KTL. And this, as I have said before, these inverters is only compatible with a smart logger. So I need a smart logger to be installed in my plant if I want to monitor my project. Okay, I will be connecting them together through RS485. And in this case, the master unit will be the smart logger. So I will be connecting all the inverters directly to the smart logger through RS485 cable, which is now I can control the whole plant and the whole project through the smart logger, which is I can do here the commissioning for all inverters. Like if I'm having 10 inverters and I want to do a commissioning, why I should go to each inverter by inverter? No, I will go to the smart logger direct and commission the whole project and the whole plant directly through the smart logger. As I said before, the smart power meter, if I'm having a case that I need to install or to power to control my power through a smart power meter, I can install it directly through the smart logger without any through the RS485 cable. Okay, in this case, I'm using the 100 KTL with the 20 KTL and the 36 KTL, and in this scenario, I'm not having any available Wi-Fi signal in my project or on my plant. So I need to use the 4G signal. So I will go directly to them. I will put the 100 KTL as a master inverter, which is it's compatible with the 4G dongle. I will connect this 4G dongle to this inverter, and I will connect the rest of the inverters directly to the main inverters, which is what my master inverter will be the 100 KTL. As I said before, if I'm having a smart power meter and I would like to connect it directly to the inverter, I will connect it directly to the 100 KTL, which is in this case is my master inverter. The whole commissioning will be done in the 100 KTL. Okay. For this scenario, I'm using multiple inverters, but I should be using the smart logger as long as I'm using one of the inverters is the 36, which is it's only compatible with the smart logger. So I will be connecting them together and put the master unit to be a smart logger, connecting them together through RS485 cable through the smart logger, and it's the same as the previous cases. If I'm having any power meter or I need to control my plant, do zero export system, as my colleague as well will also talking about this, I will be connecting directly the meter directly to the smart logger. And now we're going to my last part of the presentation, which is the large-scale C&I application, more than 10 inverters. In this case, definitely I will need to be installed a smart logger. I will be discuss one case, which is it's applicable also for another cases for multiple inverters, more than 10 inverters. I need to connect them all together through RS485 cable directly to the smart logger, as long as I'm having the smart logger. And in these cases, the smart logger will be the master unit of my project. I will do the commissioning as long as I'm having a smart logger. Why I should be going into each inverter to do a commission? As long as I'm having the smart logger, you can do the commissioning directly through the smart logger. For any meter, you can connect it directly to the smart logger. The communication with our portal will be either 4G signal or Wi-Fi signal, depends on what you're having on site. And my last slide will be about compatibility of our product with the different types, like the main features of our product and compatibility with our inverters, like the MPPTs, the arc folding, the integrated PID, smart ID curve diagnosis, supporting 4G or supporting WLAN FE, depends on the product, and you can see the compatibility of it. These slides it will be shared to all clients and partners, so you can check the compatibility of your products and to buy the new products from Huawei. Now we're going to move to some of our cases and references here in the Middle East region. For example, this is the Dubai Museum. It's 2.6 megawatt plant, commissioned in 2019, located in Dubai, UAE. As you can see here, the inverters we are recommended our inverters to be installed outdoor. This is another project done by Envirometer, located in Dubai, UAE. The capacity of the project is 1 megawatt. The COD of this project was in 2018. As you can see here, the dust, it's a very dusty area, and the generation, the inverter is still generated in this case, as long as I'm having a dusty area, which is this feature. It happens through our wide MPPT range that we're having in our inverters. This is also another case in Dubai. It's 1.2 megawatt. The COD of this project was in 2017. This one is in South Africa, rooftop project. The capacity is almost 1 megawatt. The COD was in 2019. This is a power plant in Pakistan with almost 500 kilowatt. And this project is in Oman, in Muscat, Oman. It's almost 200 kilowatt. The inverters is installed in a canopy. As you can see here, the generation. This is for an example for our monitoring platform that you can see in our platform. For example, you can see the yield, the performance ratio, the environmental saving for CO2, and the actual production of the inverter, or the power on the inverter side. As you can see here, for example, the performance ratio, as long as these inverters are located outside and outdoor installed along in the canopy, and you can see here the performance ratio is above 90.26%. Thank you very much for all of you, and we wish you to keep safe. If you're having any question, just drop it in the Dropbox, and we're having a session for Q&A. We're gonna choose 3 or 4 questions to be answered. Any other question, you can send it to us directly or to our partners. Thank you very much.
Hello everyone. Yes, I got advice to all of the guys, because in the chatting box in the right side, there have the chatting box. There have 2 options to choose. One is left your message. One is left your question. Okay, if you got a question, wanna we answer any of the event, you should left to choose the Q&A mode. Then I see you problem. Okay. Yes. Thank you so much. Thank you so much. Okay. The next step, we will welcome the Mr. Rizwan. Yeah. He will just make the presentation for introduce you 2020 Huawei Fusion Solar Smart PV. The third part. Yeah. No. The topic is zero export and how to reduce reactive power consumption. Let's welcome Mr. Rizwan. Okay, thank you.
Hello everyone, welcome to the session today. My name is Rizwan. I'm the channel CTO for the Middle East and Africa region. And thank you once again for joining us at the webinar today. So let's get started. So there'll be 3 major sections to the webinar today in regards to active control. One will be grid-side power control. The second, which is inverter output power control. And the third, which is not so popular here in the Middle East, is power radio ripple controller, which is typically quite well known for environments such as in Germany, where the grid is sending required signals to the PV plants in order for the responses to reduce power, for example, down. So let's just get started. The major components on the PV project are the PV inverter, which is the PV generator. You have the load, and then you have the power meter. The power meter would then be synchronized with the inverter, and then you have the grid. So these are the main components, and I'll go through in a bit more detail in what the differences are there. So in terms of the types of devices that are going to be connected, so as my colleagues have been going through the product range, it's 2 seconds typically if you've got a single inverter. So the response time between that power meter and that inverter responding back is less than 2 seconds. So typically that is more than adequate for a lot of PV projects. And then if you're looking at a dongle device connected up to less than 10 inverters, That then increases slightly due to the RS-485 connection between each inverter. So we normally say less than 5 seconds. Now, if you're looking at using a smart logger device, that then brings that down to less than 2 seconds as well. Now, depending on the type of power meter that you're looking to connect to, we have an approved product which is supplied by Huawei. It's a Huawei power meter, and we have two different types. We have a single phase and we have a 3-phase. Now, the single phase is more for the residential, which is covered on another topic, on another webinar. However, the 3-phase is one which is highlighted on the screen now, the model number which is supplied by, which can be supplied by Huawei. Now, there is a white list of third-party power meters which we can also use, and now that I will show you later on in the slides. Now, just slightly below, in terms of the supported inverter models, depending on the type of model, there is different types of devices that can be connected. The reason for that is some products have been released to the market slightly earlier. So, for example, the 36 kDL has been around in the market for 4 to 5 years. So this is one of our earlier generation products. So it's not compatible with devices such as the wireless dongle or the 4G dongle. So that is normally typically connected directly to a smart logger device in order to do the response or power control functionality. Now, looking at, in terms of small-scale projects, a single inverter with an export control, here is a circuit diagram on the right-hand side of how the system would be connected. And on the left-hand side, you can see the types of dongles that can be connected up, or recommended dongles that can be connected up with each type of inverter. So in terms of the wireless dongle, that wireless dongle is supported up to products of 20 kilowatts, the 20 kilowatt inverters. So if you're looking at using any of the smaller inverters, the wireless dongle can be suitable for those scale projects. And if you're looking at using potentially a bigger product, for example, a 60 kDL, then we are suggesting to use the 4G dongle. Now, in terms of connecting that power meter up, you need to make sure that the CTs which are supplied with the power meter are connected to the load, where the load is going. So ensuring that the connectivity is correct, ensuring that RS-485 plus and minus cables are correctly synchronized and connected within the correct terminals of the inverter, and that is then connected correctly with the power meter device as well. So these slides will be shared later today, and you can see here the connection of those devices to each of the power meter. Sure. So going into slightly larger projects where it's multiple types of inverters. Now, these multiple types of inverters is a very similar connection. However, between each inverter, you're now connecting an RS-485 cable. So you've got the master inverter, for example, one of the smaller inverters, less than 20 kilowatts, which can be compatible with 4G or the wireless dongle, and then the slave inverters would be then daisy chained with an RS-485 connection cable between each inverter. The connection from the master inverter to the power meters would be the same as the previous slide there. Now, on slightly larger projects, multiple inverters, which you're looking to use, and potentially you're looking at using a 36 kilowatt inverter or one of the earlier generation products, we then would suggest that connected would be with a smart logger 3000 device. So that smart logger 3000 device would be your main communication interface between the inverters and the power meter. So you have, with the smart logger 3000, you have 3 RS-485 ports, so that can be connected up to a maximum of 30 inverters per RS-485 port. And you need to make sure that you leave a separate port just for the connection of the power meter itself. Now, in terms of connecting that power meter, that smart power sensor, onto the inverter or the smart logger device, for small-scale projects, we're recommending that you use the Fusion Solar application. So when you open up the Fusion Solar application device, you would then select Quick Settings point. So once you're under Quick Settings, you've got 2 different options. You've got the smart dongle device, you've got the inverter, and you've got the power meter device. So you would select that power meter, and that power meter would then be able to be synchronized with that system of the PV project. Now, on particular cases where you want to connect it manually, that can also be possible. So on those particular cases, you select under maintenance, the maintenance section, you then adding a device. Within adding a device, you've then got two different options. You've got the battery option, which is more for the small scale projects, the residential range, which is supporting batteries, which I'll talk about in another webinar. And then you've got the power meter section. Now that power meter, you would then select that device, and then you would then have a drop down. That drop down would have the available power meters that are compatible with Huawei, and then the first one would be the Huawei supplied power meter. Now, in terms of the COM address, this is one of the most important parts, and a lot of flaws are happening on PV projects due to the communication address. Now, you need to ensure that the communication address that you're indicating for the power meter is completely separate or not identical to what the inverters are. For example, you have 10 inverters, 1 to 10, making sure that the power meter is 11 or above. Now, in terms of manually connecting up a power export control using the Fusion Solar device, an alternative way is power adjustment factor. So setting that configuration parameter up, it is power adjustment, quick type, point control. At this particular point, when you're selecting this, you would need to then re-enter the password, which for the Fusion Solar application would be the 5 zeros and a password. So this is for the security purposes, to ensure that nobody can remotely connect up and incorrectly adjust the functions of your PV system. So you would select that password in, and then you would then select active power control, and you can also see reactive power control. So there's two different sections there. So if you want to select reactive power, and that means supporting the grid with providing a reactive power, and typically that is done reactive power at night. The active power control, you select that control mode would then be power limited grid connected mode, which would then be the kilowatt value that you can then limit to the grid. Now, there's 3 different functionalities when you're doing the export control. So there's the unlimited factor, unlimited meaning that you can export all of that power to the grid. So that is, the system is directly connected, you're already monitoring how much generation is getting done, consumed at the load, and how much is being exported to the grid. So that is one of the reasons why a power meter is connected, and you're not limiting any value to the grid. The second option there is the grid connection with zero power. But that functionality is there for the purpose of not exporting any power to the grid. So as much of that power typically can be consumed by the load. However, the power meter is there to synchronize which power flow, where the energy is going, where that power is going. Is it going towards the grid, or is it going towards the load? Now, as long as the power is going in the direction of towards the load factor, the inverters will still operate at maximum power. Now, as soon as that power value is going towards the grid, the inverters are then instructed to limit down the value in order to match the power value at the load point. Now, the third option is the power limited grid connection point. Now, that is limiting a certain value which can go to the grid. So that could typically be coming from your grid operator, or it could be an agreed value with your end customer that they don't want to be exporting more than a certain value to the grid. So there's 3 different types of options, and all 3 options are available and supported with the Huawei zero export function. Now, going into a bit more detail of section 1, which is grid-tied power control, and this is going to zero power export. So this, when you're setting up with the Fusion Solar application device, you've got a section called closed loop control, and that could either be done from the inverter, or it could be using the smart dongle, and that depends on the type of solution that you're going to be using. So if it's a single inverter, typically it's just the inverter as the main device. If you're going to be using up to 10 inverters, that would then be the smart dongle or the smart logger device. If you're looking at more than 10 inverters, that would again be smart dongle or the smart logger device as well. So there's an input there which you need to then select the correct value. Now, there are certain cases where you've got an imbalanced grid, and when the CTs are monitoring the power at the grid connection point, the power meter needs to ensure that it's synchronized correctly in order to correctly function and ensure that an inverter can still output power. Now this is normally applicable for small scale applications where you've got different loads on certain phases of the power. So you've got particular air conditioning systems, you've got a heat source pump. So all of these different devices are using different power values on each phase, and that can then have a different imbalance value based on the three-phase inverter. Now, we spoke earlier on in regards to the functionality and the response time of these inverters. So when you've got these inverters connected, as you can understand, there's a communication cable going between the power meter and the inverter or the smart meter device. Now, depending on the type of devices, it's up to 5 seconds. So if you're using a dongle device with less than 10 inverters, it can take less than 5 seconds for the response time. And this is just a curve from the headquarter R&D team in the response times that we've estimated for the types of options that we are proposing. Now, referring to the power limitation with grid connection, this is then looking at two different types. So this is the grid type power limiting control. So here you can see this is a typical 10 kilowatt inverter, a 5 kilowatt inverter, sorry. You've got some power going to the grid and you've got some power going to the load. And on this particular case, we just need to highlight that the accuracy due to the communication cable going from the inverter to the power meter, there is a communication cable. So there needs to be an allowance for tolerance based on this factor. So we normally say it's around plus minus 5% value of the accuracy value going from the monitoring platform. Now, going over to section 2, which is inverter output power adjustment. So this is, again, a very simple diagram of how the technology of all the devices are connected. You've got the inverter, you've got the load, and you've got the grid. So the inverter output power is all going towards the grid. So setting this functionality up, there's various different solution options. So here you would go over the power adjustment factor, active power control, and then there is different solutions on how much or which kind of parameter you want to limit. You can do it by percentage value, you can do it by kilowatt value, you can do it by digital input values. There is various different options, and on some cases customers are requesting to do it under a frequency point. So under a certain frequency value, the inverters then need to be limited down to a certain power value. So I'll go through all of these cases in a bit more detail in the next couple of slides. So here's a solution. It's a typical 6 kilowatt system. The system is set at percent value. So it's a 50% value that can be outputted from the inverter. So once that 50% value is set, the inverter is then only outputting 50% of its allowed power to be out from the inverter point. So typically 2 kilowatts is going towards the load, 1.3 kilowatts is going towards the grid. So this is where an option of this kind of solution is used. Control over active power fixed value. So what that typically means is you've got an 8 kilowatt peak system, you've got a 6 kilowatt zero inverter, 3-phase inverter, and that's then set at 3 kilowatts. So that inverter will not be outputting more than 3 kilowatts. And that typically comes from two normal cases. You've either got the grid telling you a fixed kilowatt value, or you've got the consumer telling you that that's the amount of power that they want to be maximally exported to the grid. So there's two options. So here, where that 3 kilowatt comes in, is you've got 1 kilowatt going back and 2 kilowatt getting consumed by the load. Now, the third subject which I want to go through, which, as I mentioned in the earlier part of my presentation today, is not very popular for this kind of region, for the Middle East. It's more for more stable environments, such as in Europe, where the use of a ripple controller is used. Now, this ripple controller is normally supplied by the grid operator or another source. So typically it's provided by the grid operator, and there's two options that's available when you're using a ripple controlling device. So there's a connection of the ripple controller directly to the smart logger device, to the inverter itself, or there's a connection to the smart logger device. Now that's the two options that are available. The radio ripple controller is radio ripple controller receiver. So that's a receiving signal, it's a digital signal, which is typically coming from the grid side, which is then illustrating which power value the system needs to be connected to. So when you're connecting that system, there's 4 different points, digital points that are coming from the grid, and those need to be synchronized with the requirements that needs to be set within the Fusion Solar application. So again, you would go under power adjustment value, you would go over active power control, you would then select digital active scheduling. Once you've selected that digital active scheduling, you would then set the point of what your requirements need to be. So for example, you want 100% to be generated, you would then need to be selecting the number of signal that would need to be set on the inverter. So as soon as the digital signal is sent to a particular point, then that point would then indicate to the inverter to be 100% or to a different value. So those need to be customized, and that's normally very popular in Germany. Now, in terms of the functionality of this, here is another example, selecting 1 at the particular point, and that would then present an active power of 20%. The power factor would be 1, and then if you're selecting zeros all the way through, that would indicate 100%. Now, there's types of options when you want to use the ripple control solution. As I mentioned before, you can use and connect it using the Fusion Solar application for synchronizing and configuring that, or the second option is using the web UI functionality. So that requires a smart logger device and a connection of a laptop device directly to the smart logs to synchronize and connect that up together. Now, as I mentioned in the earlier slides, we do have various different power meters. So we have a power meter which is supplied by Huawei, and then we have a white list of power meters which are available in the market. Now, some of these are power meters which are generated from our global customers. So some, mostly of these are from the European market, and others are from Southeast Asia and South America region as well. So here's the list. We will share this presentation later today, and then you can go through exactly which power meters might be available for your various different markets. Now, we have suggested to our partners to also source or get contact details for some of these suppliers, so they can also help some of the installers or DPCs to then also have those devices available in stock or local stock, local supplies. Now, I get asked a lot of questions in regard to climate controlling, in particular in regions such as Africa and in Pakistan as well. It's very popular. You've got a diesel generator, you've got PV being installed. Now, Huawei does not supply the controlling device product with our catalog, as my colleague Mr. Omer mentioned before. So what we need to do is work with third-party companies. So what I've indicated on this slide here, it's a subject for another day, and we will talk about it with partner companies in the future. But I get asked the question quite on a regular basis. So I just want to highlight here is some of the companies which are compatible with Huawei. We've got various projects already functioning. So here is Bahrain. It's an 80 kilowatt project. It's completed in 2018, and it's a hybrid solution. You can see the inverters in the background here. The top right image is showing the generators, and these little boxes on the left-hand side are the controllers, which are supplied by the hybrid controller. So that's it for my presentation, for this section of the presentation. What I will do is say thank you very much for listening. Again, please list out any questions that you may have today on the right-hand side of the present on the chat box. And what we will do is my colleague, Omar and myself will go through those questions very shortly after my next section, which is IV curve. And I'm just going to hand it back to my colleague, Sonia.
Yes, thank you for Rizwan because the presentation is very wonderful. I think I see the chatting box, they have so many people asking for the wonderful slide. It's okay. End of this event, we will share the link. And you can just copy the link on the Google Form. You can just all download by yourself, okay? The next step is for Rizwan. As he told before, the next one is about the fusion solar smart PV. Okay, I will change the slide for you guys. Okay, the last part is for Rizwan. His topic is smart IV curve diagnosis key values. Welcome, Rizwan. Thank you so much.
Hello once again, guys. So this topic is a very popular topic and something which a lot of our customer base will be very interested in listening to today. It's IV curve diagnostic in a bit more detail. So IV curve diagnostic in simple terms is the voltage over current curve, and those curves typically indicate the health of your strings, and typically depending on that curve, on how the characteristics of that curve is, it will indicate typical flaws or problems that you're having on your site. So on the bottom left-hand side of the screen, you can typically see typical module problems. So module problems can be to deal with snail tracking, cracked modules, or backside chalking. So all of these problems indicate that the problems could be happening on your site. Now, as we all know, once the site has been installed, you typically are letting that project generate, and as long as it's generating, you will probably not maintain that site, maybe some module cleaning or some regular yearly maintenance that would be done. Now, with the functionality of IV curve diagnostic, first of all, I want to just show you the problems and what those kind of problems are on site. So here are some module problems, and now these module problems can occur on all different scenarios. Now, that can be dealt with floating projects. Floating projects are very prone for high humidity or high temperature environments, and these typical problems can start causing PID effect. Other sections are rooftops, so there is problems of other end users which are being operating at the premises. So for the health of them, any kind of issue in terms of electronics or electricity, in particular reverse current or reverse polarity, which can start causing problems of installation resistance, or fire risk because of the DC power, which being cable rods which are running along the premises of the site. Now, other options are, for example, mountain environments, so rugged and steep environments, so typically shading could be happening at certain times of the day, and other areas are utility. Now, typically this is where the mass use of the IV curve diagnostic is more focused for, and for utility scale, you can see that large areas of PV plants are being installed, and typically to monitor and maintain all of that PV, those panels and those strings, it can start being quite a lengthy process. So here is just a list of the typical problems that are happening or from our experience that could cause issues. So one of the first ones, which is PV open circuit string. So that can happen across 100% of your string. There's a risk of electronic shock for the O&M engineers. So we need to class that in various different categories. So possibility of occurrence is very high, and then that can be quite damaging for anybody operating for the O&M company. Now, I'm not going to go through each one, but you can see here the percentage and the level of severity that these kind of problems are happening. So we have understood and seen what the problem is. Now we need to find an option of resolving that issue. Now, here is another clearer example of a solution offered for mostly utility scale applications, but will also be replicable for the commercial and industrial applications as well. So the top side there is the no IV curve diagnostic system being used. So normally you've got your PV square block and there's typically errors in certain areas. Now, it's very difficult to maintain all of those PV panels and PV strings. So only 10% of those problems are probably going to be rectified on site. Now, when it comes to the second year, you will have further problems occurring, and again, only 10% of those problems will be fixed. So overall, year on year, you're going to be getting a substantial loss of generation. Now, what Huawei string and IV curve diagnostic system is offering is 100% of the scanning. So 100% of the scanning, as soon as there is an issue, as soon as you've done an IV curve diagnostic, you can pinpoint exactly what problems are happening on site with an accuracy level of 0.5%. So from year 1 to year 2, you can rectify all the issues. When it comes to year 2, any issues that are occurring, you can fix it before year 3. Now, the reason I'm saying year on year, you can do this month by month, but generally IV curve is done on a yearly basis from an O&M operator's perspective. Now, how does Huawei do this? So it's a quick fault recovery through high precision string management system. So as you probably understand, and my colleague Mr. Homer mentioned earlier on, we only have 2 strings connected up to each MPPT value. So if there's only 2 strings, we are doing a string level monitoring function. So with a string level monitoring function, if there is shading or if there is a typical low production in a particular string, we can identify that, and that can be seen using the voltage and current sensors in the incoming DC ports of the inverter. Now, the second part is the algorithms part, which is basically the curvature of the voltage versus current. So here on the left-hand side of your screen, you can see there's a curvature which is the blue line and the red dots. So the blue line is your curve of what the string should be performing from the module's supplier's perspective, and on the red line is your dots of the precision of those tests that the inverter will then basically be doing. So there is no additional devices or hardware typically that is required. You have a data logger or a communication device, which is going to go back to the Huawei monitoring platform, and that would typically be the smart dongle device, or it would be your smart logger device. So that's the 2 types of data loggers that are going to be used. In terms of inverters, it's a standard inverter. It's no modifications that is required on the inverter side. Everything's working fine, great. So just for the guys that if they did miss this slide, I just want to highlight two cases here. So the top part of the slide is, as you can see, a man standing on a particular PV module and causing shading. So that particular panel is shaded. That would then indicate that the curvature of the voltage versus current value is coming back and having a slight dip on that curve. Now that is an indication for us, and from our algorithm software, we understand that this is a problem caused to a string versus shade on a panel. Now the bottom one is indicating a string with a current mismatch, and that can be typically caused by a module which is having dust or PID effect. So we can identify that particular point, and then you can rectify that with your O&M engineer exactly when they are scheduled to come on site. Now, this is how the system works. As I mentioned, you've got all different scenarios on the left-hand side, whether that's utility scale, mountain environments, commercial applications, or fishery scenes as well. All of these scenarios are able to be synchronized, connected up to the inverter. The inverter is then feeding that information back to a Fusion Solar monitoring platform, which with a typical license, you then have an IV curve diagnostic software available. So this isn't a free platform. It is a typical paid for service. However, we are promoting this quite heavily this year of 2020. So that would then be available for trial premises for a monthly basis. Now, you can contact Huawei or your partner directly, and they can then support you in those trial licenses. Now, all of that data then comes back, and the report basically gets generated, and I'll go through how that report looks in the next couple of slides. So what are the differences? What is normally done on site using IV curve diagnostic, and what is being done when it's an IV curve diagnostic using the Huawei monitoring platform? So the key thing there is the scanning, the type of scanning. How accurate is that scanning? It's less than 1 second for one scan, so it's very quick and very precise. Now the scan resolution is 128 bits compared to 120 bits, which is normally done on the traditional IV curve diagnostic. And the energy loss, so when you're running the IV curve diagnostic, when you're switching off the inverter, you're using your manual equipment, you're having a loss of generation. Now, using the Huawei IV curve diagnostic software, it's a very minimal and very short period of time that you're losing when there is an IV curve diagnostic system operating. Now, the rest of those you can go through when the slides are shared. Now, one of the key things also I would like to highlight here is that we've also got this verified by third-party companies. Now, this is verified by TUV. So TUV have analyzed the IV curve diagnostic software offered by Huawei and its accuracy value, and they've allowed to basically categorize 14 different panel faults, and these are all listed here. So those typical faults could be to do with PV string open circuit, extensive low irradiance values. So that would typically happen when the radiation values are very low. Scanning data invalid. Typical problems can be all identified, and a short possible cause for that problem can be identified as well. So we have the fault, we have the possible cause that can be rectified, and how to rectify that issue. Now this is just another example. So it's taken roughly around 10 minutes to do an IV curve diagnostic, depending on the scale of site. So a typical 100 megawatt PV plant, utility scale, is taking no more than 15 minutes to run an IV curve diagnostic. So it's 2 minutes for the fault locating through the remote system, And as I mentioned in the previous slide, it's approved by TUV. Now, these are the typical applications that have been from our 5 gigawatts of applications that have been used using IV curve diagnostic. You can see the pie chart here in the percentage of the typical problems that are happening. Now, the most prominent one being the PV string voltage abnormal, shorted diode fault. So that is the most prominent issue that we've seen on the utility scale applications. So when you get the information come back using the IV curve monitoring platform, you will have a pie chart of the typical problems that would be happening. So on the right-hand side section, you can see some of reference projects in Asia, 50 megawatts PV site using over 160,000 panels, area of 1 square kilometer. There's a breakage of strings, 65. Breakage ratio, 1.65%. And the string yield loss estimated of around 5%. Now, when the IV curve software is run, it then generates a PDF document of a report. So that report will basically illustrate what are your typical problems on site. So here is an example of a couple of the first pages that comes back. So you will have the first page which will show you the healthy strings and the defective strings. So the healthy strings most likely would be the highest percentage, and any issues that would be happening would be highlighted in the red section. Now that red section is then broken down into different segments of what kind of problems would be happening on site. So those 14 different panel faults would then be indicated or included in those. Now, there's no limitation when you're running the IV curve. Once the license is provided to you as the customer or to you as the EPC or an M operator, you are able to run the IV curve diagnostic as many times as you wish. So there's no limitation on the times. Now, here's another example. As you can understand here, it's a mountain environment, so it's a very complex terrain and very difficult for the O&M operators to operate on site. So you want to be spending as minimum time for those guys that are going to be operating on site to go around checking defaulted strings on site. So using a remote system such as the IV curve diagnostic from Huawei, everything can be generated remotely. And here's just an example of a report where there is a fault rate of around 4.7%. Now, another issue that we can identify is the module with hot spotting. So it's very difficult to identify this with a naked eye. You would require a thermal imaging camera. So once the IV curve diagnostic is done, it will then generate a report. So we'll run a report like this. That report will then indicate a normal curve near the PVT of the PV string, hotspot, hidden crack or glass breakage. So you can identify and send your engineer directly to that string point where the issue is happening. So their thermal imaging camera will be sent for a very short period of time to rectify that issue. Now, other issues could be diode short circuit. So in terms within the PV module itself, the diodes, the 3 typical diodes within the PV modules, and one of the diodes could be defective. So that can also be identified within the IV curve diagnostic software as well. Now, some things which are kind of very less checked on site is the risk of shading. Normally the PV system is designed in order to have minimum to no shading. Now again, we're using the IV curve diagnostic software. When it's run the report, typical areas of the PV panel are caused by having a shading impact. So you can see here the shadow effect is causing the curvature to change. Now I can go on and on with a number of different issues that could be happening. The curve will differ at every different case. So this is just an example of the different problems. And if you're looking at floating solar projects, bird droppings is a very common one. So this one can be identified with the PV string mismatch happening on site. Now, if you're not aware already, one of the most recent utility scale projects which was connected to the grid last year, which was in the name of Sakaka, it's a 405 megawatt PV peak project. It's one of our key reference projects, and on that particular site, we've also allowed our customer to run an IV curve diagnostic system using the Huawei IV curve software. They've also used a traditional solution of IV curve, so they've compared and we've analysed what is the cost-saving exercise using the IV curve for traditional versus the software-based that is offered by Huawei. So just to give you a quick glance over, in terms of tool cost is around $47,000. In terms of time consumed, it's around 30 days to run the 405 megawatt site. So that would then consist of many labour engineers. So that would then be the labour cost of around $24,000, and then the total cost would be around $75,000. So there's quite an extensive cost in order to do that for a period of 1 month. So that's an IV curve diagnostic one time only. So if you're doing that multiple times per year, or you're doing that multiple times over the operating time period of that PV project, that will then mount up to quite a large portion of value. So this software is paid for. It's at a very low rate compared to the traditional system, and it's more accurate and more consistent compared to the traditional system. So just to kind of conclude on the slides now, overall we've had about 5 gigawatts of applications which are used with the IV curve diagnostic software. We've installed it, we've used it for many different scenarios. Utility scale in Turkey, we've done a project with 40 megawatt on a utility scale application. Floating solar, which is very popular in Southeast Asia environment. Commercial rooftop applications is also becoming quite a popular choice as well. And in terms of the third-party verification, we have a third-party test report which is approved by TÜV. So this is one of the kind of leading edges that is offered by Huawei, and this is something which our competition products that are available in the market, they can't offer such options such as the third-party test report. This is approved by TÜV, so all of the panel faults which I mentioned before are all verified and approved. So this test report is available on request from our partners or from contacting Huawei direct. Now, thank you very much again for the time today. Sorry for the technical issues that we encountered over the last 1 hour with the session that we've been going. Hope you enjoyed the presentation. I'm just going to hand it back over to my colleague Sonia. Thank you very much.
Thank you. Thank you, all the attendees. Thank you so much. Here have follow our invitation letters as the first part. The first part is about to exploring Huawei SGIEC. This video, my colleague told me now we are already done, so we can play the video right now. Thank you so much. Give me a second. I will just play this video. Screen see the okay now which one Omar, Mr. Omar can choose 3 or 4 questions and to sharing.
The first question I would like to take is this one. Okay. Can we combine meters and manage export limitation based on the total consumption?
Can we manage the, it's not on the screen, so let me just read that out again. So can we command meters and manage export limitation based on the total consumption? Now, in order to do such case, you will need a hybrid controller. So if you want to send a particular power value to the inverters, you would then need a grid controller, so a hybrid controller we call this on this particular case. So it wouldn't be the normal case, and on a particular case like this, you would need a third-party hybrid controller. On this particular case, what I would suggest is contact me on my email address, and I'll be happy to support you with further information on this. Next.
Okay. If connecting two inverters with RS485 difficult, like laying cable between two inverters due to road, can we connect two inverters wirelessly?
That's not possible using our solution. So the reason why that's not possible is the stability of the wireless connection. We and myself with an EPC have experienced a case like this in the past, and actually the wireless connection is not a very stable solution, and you would have intermittent loss of signal. So on a particular case, my suggestion on this solution would be just purchasing two 4G dongles and connecting them up to the inverters.
Okay. I have a query. Normally, the data sheet mentions the total harmonic distortion contribution from inverter, but I am more concerned about the inverter's capabilities to deal with the total harmonic distortions that are traveling from load into the inverter. What is the capacity of inverter to safeguard from the total harmonic distortion being contributed by the load ends to the inverter, like maximum percentage of the total harmonic distortion that inverter can manage? And what is the maximum order of harmonics that inverters can manage with a reliable operation?
Okay, so in particular question, I think I've recently been asked that over an email. So that the inverters are following the voltage values on the grid side. So in terms of your load would then fluctuate and produce a curvature in terms of the voltage. So if there is a voltage increase, that would then increase the harmonics that are caused on the voltage side. In terms of current, the inverters are just providing a current source, so that would not be impacting the inverter. So there's not going to be any impact on the current value of the inverter itself. Next one, question.
Okay. Here is they are asking, is the IV curve diagnosis feature paid?
Okay, so I'm sorry if I have not made this clear in the presentation today, but the IV curve diagnostic software is a paid for service. So it's a chargeable yearly subscription per megawatt for our customers. Now, as I mentioned in the presentation today, the IV curve diagnostic system, we are promoting it quite heavily for a lot of our customers for the CNI and utility scale applications. So we are giving free trials for periods of time this year. So just contact your partner that you're purchasing the inverter from, and they can discuss the amount of time that we can provide the trials for. Last question, I think.
Last question. How does your software identify performance ratio without a weather station radiation sensor? Is it reliable enough in this case of the performance contracts?
Okay, so we have, in terms of performance ratio, there's a standard equation that we're working with. So that performance value, I can share with you the calculation that we're using. So how the performance ratio is working is that you are inputting the DC kilowatt peak into the system. So the DC from the panels which are connected to each inverter, you can then duplicate that to the number of inverters that you're connecting up to your system. And once that is connected, the inverter will then have an equation based on its AC output, its yield, and it will give you a value in terms of its performance ratio. Now, a radiation sensor should be connected and can be connected onto the monitoring platform as well. So just to conclude on that question, my suggestion is send me an email on that. I'll send you the detailed calculation on how performance ratio is calculated using the Huawei monitoring platform. I think that's it on the questions. We shall take note of all the questions today from our system, and we'll try to get back to as many people as possible using an email back to all of you on the answers on those.
All the presentation will be shared into the link, so we're going to share it with the clients, okay, so they can download all the presentation from the
Sure. So yeah, the presentations which were presented today will all be available later today or early part of tomorrow morning to be available to download from a link online. Thank you very much, guys, and I hope you have a good evening, and hopefully we will see you very soon at the next webinar. And apologies once again for the small technical issues that we suffered, and have a good evening and Ramadan Kareem.
Okay, thank you guys so much. We now, before the video got some problems, so my colleague advised me to play a new one for you guys. This one, the name is called South Factory Rooftop Planning video. Thank you so much.
Welcome to the Huawei Southern Factory Smart PV demo site. My name is Ethan, and it is my great honor to guide you through the site today. The capacity of the Southern Factory, and it is my great honor to guide you through the site today. The capacity of the Southern Factory rooftop PV plant is 17.5 megawatt, and it can generate about 17 gigawatt hour of electricity per annum. The demo site shows the distributed PV plant solution and optimal LCOE design for utility PV plant. Now, let's have a tour of the plant together. Huawei string inverter passed comprehensive reliability tests like highly accelerated life test and temperature humidity bias test, etc. With IP66 high protection level, the inverter can operate stably in various harsh environments. Here, for example, we can see inverters running under heavy water jets, and some inverters are running in high temperature heating chamber. Huawei inverters were deployed over 118 gigawatts globally, and its annual failure rate is less than 0.4%. Now, let's go to explore the distributed PV plant together. Next, you can see the area of residential scenarios. For residential scenarios, Huawei is committed to bringing 3 core values to customers: active safety, high yields, and better experience. The application scenario of distributed PV solution is mainly on the roof of industry and commercial building or family house, so the system safety is critical. Among them, DC arcing caused by loose PV connector or damaged PV cable, etc. is one of the main hidden fire hazard. Arcing can reach a temperature of 3,000 degrees Celsius in a short period of time, which can burn the insulation layer of the cable and cause a fire. Meanwhile, the fire caused by this kind of electrical equipment will also put a great risk of electrocution to firefighters. Huawei introduced the AI-powered active arcing protection. By detecting the electrical noise waveform of DC arc and comparing it with that in the database, it can confirm whether DC arc is generated within 2.5 seconds and shut down the system to ensure that the arc is extinguished immediately. AI-powered active arcing protection meets the US UL 1699B standard and is industrial leading. At the same time, the application of AI self-learning technology enables the inverter to continuously record and identify new arcing noise waveform during the operation, so as to realize the more inverter get used, the smarter and safer it becomes, and ensures the high reliability of the PV plants in the lifespan. In the residential scenario with optimizers, Huawei AI-powered active arcing protection can not only shut down the system, but also accurately locate arcing to module level. Therefore, the O&M personnel can get the specific arcing position through the APP without attend to the plant, which saves a lot of effort. Another big challenge faced by distributed PV solution is that the rooftop structure is relatively complex, and the external air conditioner, billboard on the roof, and antenna of base station, etc. may shadow the solar panels, thus affecting the yield. We have imitated a house rooftop and installed 24 pieces of PV modules equipped with the Huawei optimizers, which are distributed in the east, west, north, and south sides of the roof. If other system is like ours, the rooftop PV module layout design can make full use of the rooftop area, and the PV modules with different orientations can be connected into one string. It can ensure that the output current of the PV module will not be affected when it is in the shadow, and the yield of other PV modules in the string will not be affected. Compared with no optimizer, it can reduce the yield loss. The volume of the second generation optimizer is reduced by 50%, which can be held by one hand, and one model can match all models of PV module. So the installation is easier. Huawei adopts AI module auto mapping technology, which can automatically generate physical layout of PV modules within 5 seconds, saving 99% deployment time compared with traditional manual process. Huawei's unique patent AC terminal can reduce installation to 30 seconds. Single-phase and small three-phase inverters are integrated with battery interface, supporting easy expansion at any time. In the future, there will be self-developed energy storage system and backup box to ensure the consumer's self-use rate. Next to the residential scenario, there will be a C&I scenario exhibition area in the near future. Please stay tuned. Next, let's go to explore the optimal LCOE scenario of utility PV solution. Now we are in the optimal LCOE scenario for utility PV plant. In order to achieve lower LCOE, the design of 1500 volt string inverter plus bifacial module plus tracker system is highly recommended. Let's take a look at this site. Two of 175 kilowatt 1500 volts inverters are installed. Each inverter is connected to 2 strings. Each string has 34 pieces of 310 watt N-type monocrystalline half-cut cell bifacial dual glass modules in series, installed on the single access tracker. The AC cable of the output side of the inverter goes to the transformer station in the distribution room. At the same time, M-bus power line communication is transmitting the inverter data to the management system. 2 strings of the right-handed side inverter are connected to the same MPPT, and their real-time operating voltage will be identical. 2 strings of the left-hand side inverter are connected with 1 MPPT respectively. so both strings can work at their maximum power point. We conclude that the difference in the number of MPPTs in the array will result in the difference in yield, and the string mismatch of the left-hand side inverter should be lower, therefore having higher yield. Later, we'll go to the management system to check the yield data to confirm the inference. Besides, we can see that the ground condition of the two strings is different if we observe it carefully. The ground of the near string is grass, which often has lower albedo, while the ground on the further away string is cement, which has higher albedo than grass. Therefore, we infer that the power of the near string in the management system should be able to verify our inference. Last but not least, the single access trackers on site integrates Huawei AI-optimized tracking algorithm. According to the on-site environment, the optimal tracking angle can be deduced through neutral network learning to increase the yield further.
Finish this top time. And can you just guys see the pages on the screen? This is about the community solar Huawei, and you can just scan the QR code and join us. Yeah, join us maybe in the next webinar. We can just register on this website. Yeah. Okay, thank you guys so much. Thank you guys so much for today's attendee. We will see you next time. Bye bye.